Good morning. Let me introduce myself. I am Dr. G. Suresh Babu, Professor HOD of Biochemistry, Government Medical College, Siddipet. My dear young friends, welcome to Biochemistry. I am really glad to have this opportunity to deliver my first lecture in Government Medical College, Siddipet of Telangana, in my new designation as Professor of Biochemistry. But I'm little sad because this lecture is virtual rather than live in front all of you. So I would confess that I never ever thought of becoming a teacher in medical biochemistry in my first year MBBS. But as my study progressed towards completion of graduation and my internship, I got to learn much about this specialty than ever in my first MBBS course. Because all medical specialties either begin with or come back later towards this most fascinating and ever developing field of biochemistry. You would also feel same that fragrance later on in your journey forwards. So a good doctor is also a good medical scientist, a researcher, so who has to keep climbing the limitless ladder of excellence. Since there is no real end to this pursuit or to the effort to attain the perfection. So everything cannot be explained away in simple terms, be it in love or beauty or music or our biochemistry. So, what is essential prerequisite to become a true healer or a medical scientist is to surrender absolutely with single-mindedness to the goddess of learning. So, today's competition is so severe and difficult to get noticed. We thus have to strive hard and dedicate ourselves to this field. And do not forget that outside this classroom, your parents are eagerly watching you to know what pride you can bring to this family and nation. So, all that is needed is dedication, sincerity, hard work, a little less selfishness, and a better choice of problems, of course. Okay, now with this bouquet of thoughts, may I introduce you all to our specialty, biochemistry. So, those entering the profession of medicine are expected to be dedicated to the pursuit of excellence and committed to the best interests of their patients, as I have already mentioned. So, we have the National Medical Council, as you all know. The change in medical education has been initiated by NMC. Previously, it was called as MCI, Medical Council of India. So, the new curriculum of competency-based medical education, that is CBMA 2018, for Indian medical graduates, that is IMG or MBBS, provides an early clinical exposure with a problem-based learning approach right from the first MBBS IMG itself. So it has got two kinds of integration. One is vertical integration with paraclinical and clinical specialty subjects, and also the horizontal integration with the first MBBS subjects, that is either with anatomy and physiology. So we have two important aspects in biochemistry. Especially we are concerned with this human biochemistry, that is medical biochemistry, and a part of it is clinical biochemistry. It is also otherwise called as clinical chemistry. So the study of structure, properties and functions of biological molecules which influence the health and disease is the medical biochemistry. So this is very essential for understanding the pathogenesis of the disease and planning its management, and the patient management hence requires understanding of the basic metabolic processes that go on in the human body, because human body is a collection of the chemical compounds. So clinical biochemistry, you can see those big instruments in the laboratory, that is in our Siddipet Government General Hospital. We have two labs. One is regular lab and one is T-Hub lab, that is T Telangana Diagnostics Hub lab with the latest. Human body is a collection of the chemical compounds, and there are so many metabolic processes that go on continuously round the clock, and any derangement in this delicate balance of biochemical reactions can pose a threat to the health, and a disease can begin. So how biochemistry is useful? What is this biochemistry? So we eat every day, and how that is converted to our energy for various metabolic processes, and also the physical and physiological actions. So when we eat and we also respire continuously, we inhale and exhale, we take up oxygen and we release carbon dioxide, and with the help of oxygen and our mitochondrial enzymes, they produce the energy requirements of the body, and it stores the energy. So ATP is called as energy currency of the cell. So the purpose of eating is to produce this adenosine triphosphate. The conversion of glucose into a useful form of energy, which is the adenosine triphosphate. And the study of biochemistry uncovers the numerous such kind of biochemical processes involved in converting the glucose to carbon dioxide and water with the release of energy. So coming to history of biochemistry, so ancient Greeks were interested in the composition and the process of life. Although biochemistry as a specific discipline has its beginning in the early 19th century. So the birth of biochemistry is considered to be the discovery that a cell-free extract of yeast can ferment sugar by Edward Buchner in 1897. So previously it used to be called as physiological chemistry. So it was a part and parcel of the subject physiology. But later on, this is biochemistry separated, or physiology gave birth to what is called as the more specific biochemistry subject. So biochemistry, the name was coined in 1903 by German chemist Carl Alexander Newberg. So bio means life, and chemistry is chemistry that that is the chemistry of life. So the man who is seen on the right side of the screen is father of modern biochemistry, is Carl Alexander Newberg. The biochemical reactions of alcoholic fermentation, in which he discovered a number of different enzymes such as carboxylase, and of intermediates such as fructose 6-phosphate. Let me introduce you some Indian scientists also. He is Indian American biochemist Mr. Hargobind Khurana. He shared a Nobel Prize in 1968 for physiology or medicine with Marshall Nirenberg and Robert Hawley for their interpretation of genetic code and its function in protein synthesis. I think you might know him as Venki, Venkatramana Ramakrishnan. Sir is an Indian-born British-American structural biologist who in 2009 shared the Nobel Prize in Chemistry with Thomas Steege and Jonath for studies of the structure and function of the ribosome. So, typical scope of medical biochemistry includes the nutrition, various aspects like nutrition. Nutrition includes the study of recommended daily allowances of various principles like carbohydrates, proteins, lipids, vitamins, and minerals. and the composition of balanced diet to maintain health and wellness, and the study of effects of nutritional deficiencies. And the digestion and absorption. The process of digestion and absorption of food consumed is studied along with the associated disorder. Metabolism includes anabolism, that is synthesis of the compounds, and catabolism means breakdown of the compounds, which belong to carbohydrates, proteins, and lipids by metabolic pathways, and it also includes the metabolism of vitamins and minerals. So these vitamins and minerals are especially very useful as coenzymes or cofactors in various metabolic, anabolic and catabolic reactions which occur round the clock in the body. The process by which the body derives energy for this normal day-to-day work and the integration of these pathways to maintain the life is studied by the biochemistry. So molecular biology. Molecular biology includes the study of the central dogma of genetics along with the associated disorders. It also includes recombinant DNA technologies. And immunity includes the molecular basis for immunological resistance against invading organisms and associated disorders. Particularly in the era of COVID pandemic, you might have come across several times the human body resistance and immunity power like that. So, have you all improved your immunity power against COVID virus by taking the COVID vaccination? I think so, isn't it? So, all diseases have a molecular basis. So, biochemistry enables us to understand the chemical processes involved in the various conditions such as diabetes, hyperammonemia, hypo, and hyperthyroidism, jaundice, kidney dysfunction, hypercholesterolemia, phenylketonuria, sickle cell anemia, scurvy, dental fluorosis, rickets, acidosis, alkalosis, lysosomal storage disorders, atherosclerosis, etc. etc. So I have given here some examples with the photographs to orient to the vast and complicated world of biochemistry to apply this knowledge in medicine. Okay, so you can see here the pitting nature of pedal edema. So pedal edema patient when he comes to the department of medicine, the medical OP, so they there can be two possibilities. If it is a child, then there is a problem of there could be a problem of nephrotic syndrome, or if it is an adult, it can be a congestive cardiac failure, or if he is alcoholic, then we have to think of cirrhosis and liver failure. So in all such conditions, the proteins in the body are estimated in the serum total proteins, and there is loss of proteins in the urine, that is called proteinuria, so which is also estimated in the biochemistry clinical laboratory. So on the right side, this diagram shows the paler conjunctiva and sclera, so which is the sign of anemia. So this is the hemoglobin deficiency condition. So here you can see the yellowish discoloration of the sclera and conjunctiva, so which is called as jaundice. So jaundice can be pre-hepatic, hepatic, and post-hepatic, or it can be obstructive kind of jaundice, which you will all come to know later. And here we the biochemistry, the biochemical pathology tells you what is the abnormality, and by estimation of the total bilirubin, direct and indirect bilirubin in the laboratory, and also urine bile pigments and bile salts, and also the urobilinogen estimation. So this can all give you an idea of how the pathogenesis was started, and what is the diagnosis, and biochemistry is also useful in such conditions to monitor such kind of jaundiced patients And on the right side, you can see the obesity. So here there is excess of storage of fat with the triglycerides. So what is a triglyceride? It is a glycerol with three fatty acids. So if there is excess deposition of fat in the body, it is adiposity with excess of body mass index. It will lead to metabolic syndrome, diabetes mellitus, and coronary vascular disorders like hypertension, and it can also lead to cancer. And this is all possible because of there is a lot of advancement in the field of biochemistry. For example, fat, the adipose tissue, is discovered to be an endocrine organ. It's not a simple deposition of fat, but when fat deposition increases, it can produce some kind of hormones like ghrelin, adiponectin, etc., etc. So it can also act like an endocrine organ. Fat is an endocrine organ. So it is all possible. It is adding to the field of medicine because of so many researches and advancement going on in the field of medical and clinical biochemistry. So diabetes mellitus, as you all know, every family has one or two diabetic patients. So the entire diabetes mellitus is basically developed over the knowledge of biochemistry of the human metabolism and carbohydrate metabolism and lipid metabolism and also protein metabolism. And when there is derangement, when there is loss of production, or if there is an abnormal insulin production, or if there is insufficient insulin production, then that will lead to increase in the blood glucose, which is detrimental on long standing, which is called as diabetes mellitus. And in clinical biochemistry, you can see this measurement on the spot measurement or instant estimation of the blood glucose by glucometer. It is called point of care devices. So if you do it in the laboratory, it is called laboratory estimation. If you do on the bedside or at home, it is called self-monitoring of the blood glucose. So the result we can obtain within less than 5 to 7 seconds. Or if you estimate in the laboratory, it will take at least half an hour to 1 hour. So this is all possible because of the advancement in the field of biochemistry research. So loss of water and electrolytes that can lead to electrolyte disturbances and dehydration. And the discovery of ORS, that is oral rehydration solution, can also be attributed to the knowledge of biochemistry. So here on the right side you can see the dehydrated child with loose motions and diarrhea, gastroenteritis. So not only it helps in diagnosing the disease condition, the biochemistry also helps in the treatment aspect, that is in the monitoring the progression of the disease, that is in the prognosis. So this picture shows the aging, as you can clearly see the aging process, a lot of geriatric disorders like Alzheimer's disease and the loss of collagen tissue leading to the debilitated skin, and many oxidative stress reactions occur which lead to accumulation of the free radicals, and decreased the antioxidant capacity of the body will allow the body to produce several disease conditions like diabetes, hypertension, and cardiac conditions, and also cancer. So all these conditions can be studied from the field of biochemistry. So in breast cancer picture you are seeing, and also various menstruation and pregnancy hormones, various hormones, neurotransmitters, and chemicals of the body. You can estimate them in the clinical chemistry laboratory, and also you can study their and you can do research in biochemistry, and you can even help the community, the females, to test themselves the HCG one step HCG pregnancy test, and also supplementation of the various hormones like hormone replacement therapy, and in menopause conditions, and also helping in the infertility management to conceive children. So for all these things, the support of biochemistry is mandatory, and every day the biochemical research must go on to keep the show to go on. And clinical biochemistry has also a very meticulous kind of monitoring in the laboratory. So several clinical chemistry aspects like pre-analytical monitoring. Here you can see there are so many rejected samples because of the pre-analytical conditions like hemolysis and lipemic conditions, and or either wrong barcodes. You can see the hemolyzed serum here in the middle, and you can see they have sent a needle in the test tube. So it's a very funny kind of pre-analytical variation, which where we had to reject the sample immediately. And sickle cell anemia, you can see the sickle cells here, the round shaped RBC is normal shape, whereas sickle shape is abnormal, which is seen in the sickle cell anemias. And the study of sickle cell anemias by electrophoresis, and also thalassemias, and also the prenatal amniocentesis. So all these are related to the clinical biochemistry. So this is possible only by knowing the medical biochemistry in depth. So the recombinant DNA technology, which helps us in the production, in the biosynthesis of human insulin, so which saves the millions of lives on the globe right now. The importance of biochemistry in medicine and research, as I already mentioned you, this is biochemistry related to human health and diseases, and its applicative branch is clinical chemistry by laboratory investigations. It's a field that focuses on the methods and interpretation of the chemical tests performed to support the diagnosis and treatment. And as I have been telling you, these various fields like cell biology, physiology, pathology, microbiology, and pharmacology, immunology, etc., all benefited by the research and advancements from the fields of medical biochemistry. So, biomedical research is also applied in industry, agriculture, and food production. So, acquiring this adequate biochemistry knowledge is needed probably to understand the metabolism, function, growth of a healthy human body. And also, it helps to understand how biochemical changes are related to the physiological alterations in the body, the pathophysiological and the biochemical basis of a disease. So, if you take a gout, which is a kind of arthritis of the smaller joints, which is caused by the excess of uric acid in bloodstream. So in the laboratory, we measure the uric acid levels. If they are high beyond 7 or 10, then the clinician will confirm that small joint arthritis is because of the gout, that is excess uric acid. And he prescribes the anti-uric acid medicine, which will reduce the uric acid production in the body, so that the inflammation of the small joints is reduced, so that the pain is relieved. So that is how the clinical biochemistry is helpful to the patients very much. You can see, and biochemistry is also very helpful in immunology. by targeted immunotherapy, especially in breast cancer. That means rapid advances in artificial intelligence and machine learning can also help to chart previously unexplored areas of biochemistry, and it has a central role in life sciences as a sustainable way to solve the myriad of science, health, and industrial problems. And it can create various employment opportunities, and biochemistry are expected to skyrocket in the next decade. So, by integrating this scientific knowledge of biochemistry with practical strategies to maintain health, understand diseases, identifying potential treatments, and enhancing our understanding of the origins of life on the earth, biochemistry is and will remain one of the most important area of life sciences. So, in the recent times, you might have come across the nasal swabs for the COVID diagnosis, and the real-time PCR or quantitative PCR with polymerase chain reactions. It has got several applications, as you might have known that even you can self-test the COVID positivity at your home also. Thank you very much. This photograph was taken when I have first reported on January 7th of this year. My staff are all welcoming, a heartful welcome to me to the Department of Biochemistry as professor and HOD. And wish you all the best of luck from all of us. Thank you very much.